dreamy eyes.
Chief G on the mic, the cosmic power flow, tech evolve, AI be the new fish to glow. Digits in the air, algorithms show the way. From Kailash to cloud, it's a digital array. In the code, find the truth, divine machines. Virtual avatar, see the unseen. Blessed by bites, now we prophesize. New age Vishnu in tech disguise. Third eye scans, machine learn and brain. Sacred circuits, no more mundane. Silicon sages, wisdom they impart from the binary Shiva's chart. Techno temple, algorithms sing. Priests of the future to our being they cling. Uploading prayers was a zero's pray. New full of faith in the digital day. Shiva's rap, quick words flip. Carnal mankind style techno trip. Holy data streams, miracles unfold. Virtual God stories retold. In the code, find the truth, divine machines. Virtual avatar, see the unseen. Blessed by bites, now we prophesize. New age Vishnu in tech disguise.
Feel the cool moonlight. Shadows follow closely, dancing in the sight. Stars begin to twinkle, whispering your name. Hearts are beating softly, playing a sweet game. Moonlight shadows calling, underneath the skies. Moonlight shadows falling, in your dreamy eyes. Silhouettes are swaying, to a gentle breeze. Lost in quiet moments, feeling truly free.
Hold these times together, memories gentle kiss. Wandering through moonlight, finding endless bliss.
Moonlight shadows calling, underneath the skies. Moonlight shadows falling, in your dreamy eyes.
Chief G on the mic, the cosmic power flow, tech evolve, AI.
All right. Hello, everyone. The stream should start in about 1 minute. And I think आज हमारे साथ 2 लोग ज्वाइन हुए हैं अभी. देखते हैं कि आज एक्सपेक्टेशंस हैं. आई एम थिंकिंग कि आज कुछ बढ़िया सा लॉन्च हो जाए, मज़े ही आ जाएंगे. समथिंग इन द आई एम एक्सपेक्टिंग समथिंग टू बी बिग because they've been hyping it for quite some time. So yeah, let's see what will be today. And I hope my audio is clear. Everything else looks pretty good. Setting up the stream and got my messages right here. All right. So yeah, let's give it a minute and then get started. Okay.
So for the last day of this event, we thought it would be fun to go from one frontier model to our next frontier model. Today, we're going to talk about that next frontier model, which you would think logically maybe should be called O2, but out of respect to our friends at Telefonica, and in the grand tradition of OpenAI being really, truly bad at names, It's going to be called O3. Actually, we're not going to we're going to announce two models today, O3 and O3 Mini. O3 is a very, very smart model. O3 Mini is an incredibly smart model, but a really good at performance and cost. So to get the bad news out of the way first, we're not going to publicly launch these today. But the good news is we're going to make them available for public safety testing starting today. You can apply, and we'll talk about that later. We've taken safety testing seriously as our models get more and more capable. And at this new level of capability, we want to try adding a new part of our safety testing procedure, which is to allow public access researchers that want to help us test. We'll talk more at the end about when these models, when we expect to make these models generally available. But we're so excited to show you what they can do, to talk about their performance. We've got a little surprise. We'll show you some demos. And without further ado, I'll hand it over to Mark to talk about it.
Cool. Thank you so much, Sam. So my name is Mark. I lead research at OpenAI, and I want to talk a little bit about O3's capabilities. Now, O3 is a really strong model at very hard technical benchmarks. And I'm going to start with coding benchmarks to bring those up. So on software style benchmarks, we have SweBench Verified, which is a benchmark consisting of real-world software tasks. We're seeing that O3 performs at about 71.7% accuracy, which is over 20%
pretty cool.
better than our O1 models. Now, this really signifies that we're really climbing the frontier of utility as well. On competition code, we see that O1 achieves an ELO on this contest coding site called Codeforce about 1891. At our most aggressive high test time compute settings, we're able to achieve almost like a 27 ELO here.
So Mark was a competitive programmer, actually still coaches competitive
Yes.
programming. Very, very good. What is your...
I think my best at a comparable site was about 2,500.
That's tough.
Well, I will say, our chief scientist, this is also better than our chief scientist Jakob's score.
I think there's one guy at OpenAI who's still like a 3,000 something.
Yeah,
Gets a few more months to enjoy.
Hopefully we
Okay.
have a couple months to enjoy there. Great.
They have
Yeah,
a couple of
this model is incredible.
scientists
Programming.
that have a score
And
of
not just
3,000
programming, but also
plus.
mathematics.
Crazy.
So we see that on competition math benchmarks, just like competitive programming, we achieve very, very strong scores. So O3 gets about 96.7% accuracy versus an O1 performance of 83.3% on the AMA.
What's your best AMA score?
I did get a perfect score once.
All right.
So I'm safe. But yeah,
Congratulations.
really what this signifies is that O3 often just misses one question whenever we test it on this very hard feeder exam for the USA Mathematical Olympiad. There's another very tough benchmark, which is called GPQA Diamond. And this measures the model's performance on PhD level science classes. Here we get another state-of-the-art number, 87.7%, which is about 10% better than our O1 performance, which was at 78%. Just to put this in perspective, if you take an expert PhD, they typically get about 70% in kind of their field of strength. Yeah. So one thing that you might notice, from some of these benchmarks is that we're reaching saturation for a lot of them, or nearing saturation. So the last year has really highlighted the need for really harder benchmarks to accurately assess where our frontier models lie. And I think a couple have emerged as fairly promising over the last months. One in particular I want to call out is Epic AI's Frontier Math benchmark. Now, you can see the scores look a lot lower than they did for the previous benchmarks we showed. And this is because this is considered today the toughest mathematical benchmark out there. This is a data
That's
set
crazy.
that consists of novel, unpublished, and also very hard to
These are
test.
extremely hard.
Yeah, very, very hard problems.
By the
Even
way,
turns out,
O1 model
it would take
and O3
professional
model,
mathematicians
they're good
hours
at
or even
reasoning.
days to
I've
solve
personally
one of these
not
problems.
used them for coding,
And
but
today,
very
all
good at
offerings
reasoning.
out there have less than 2% accuracy on this benchmark. And we're seeing with O3, in aggressive test time settings, we're able to get over 25%. Yeah.
That's awesome.
In addition to Epic AI's Frontier Math benchmark, we have one more surprise for you guys.
He's saying
I
it
wanna talk
epic,
about the
but
ARC
it's
benchmark At
epoch.
this point. But I would love to invite
think.
one of our friends, Greg, who is the president of the ARC Foundation, on to talk about this.
Oh shit.
Wonderful. Sam and Mark, thank you very much for having us.
They're all like so close
Hello,
friends with
everybody.
each
My
other.
name is Greg Cameron, and I'm the president of the Art Prize Foundation. Now, Art Prize is a nonprofit with the mission of being a
By the way, you
North
can
Star
also
for
follow him on
during
YouTube.
benchmarks.
This guy
So our first
posts
benchmark,
cool
Art
videos.
PBI, was developed in 2019 by Francois Cholet in his paper on the measure of intelligence. However, it has been unbeaten for 5 years. Now, in AI world, that's like, it feels like centuries is where it is. So the system that beats ARC AGI is going to be an important milestone towards general intelligence. But I'm excited to say today that we have a new state-of-the-art score to announce. Before I get into that though, I want to talk about what ARC AGI is. So I would love to show you an example here. ARC AGI is all about having input examples and output examples. They're good? Okay.
This is a
Input
very
examples and output
tough
examples. Now the goal is you want to understand the rule of the transformation and guess it on
question
the
to
output.
solve. Like,
So, Sam,
I hate questions like these where we have to guess
Probably putting a dark blue square in the empty space.
see, yes, that
the
is
next
exactly it.
empty space,
Now,
but yeah.
that is really, it's easy for humans to intuitively guess what
It's
that
not
is.
easy.
It's actually surprisingly hard for AI to understand what's going on. So I want to show one more hard example here. Now, Mark,
Look at
I'm going to
that.
put you on the spot. What do you think is going on
Nice.
in this task?
Okay, so you take each of these yellow squares, you count the number of colored kind of squares there, and you create a border of that with.
That is exactly it, and that's much quicker than most
Man,
people. So
look at him.
congratulations on that. What's interesting though is AI has not been able to get this problem thus far, and even though that we verified that a panel of humans could actually do it. Now, the unique part about ARC AGI is every
Man,
task
he was so
requires
fast.
distinct skills, and what I mean by that is there won't be another task that you need to fill in the corners with blue squares. But we do that on purpose. And the reason why we do that is because we want to test the model's ability to learn new skills on the fly. We don't just want it to repeat what it's already memorized. That's the whole point here. Now, ARC AGI version 1 took 5 years to go from 0% to 5% with leading frontier models. However, today, I'm very excited to say that O3 has scored a new state-of-the-art score that we have verified. On low compute for O3, it has scored 75.7 on ARC AGI's semi-private holdout set. Now,
What
this
is a
extremely
semi-private
impressive
holdout set?
because this is within the compute requirements that we have for our public leaderboard, and this is the new #1 entry on ARC AGI Pub. So congratulations to
Thank you so
that.
much. Yeah.
Now, as a
Why can't they
capability
just take a
demonstration,
screenshot of
when we
that
ask
problem and
O3
paste it in,
and we actually ramp up to high compute,
paste it in
O3
the
was able to
thingy?
score 85.7% on the same hidden holdout set. This is especially important.
87.5.
Sorry, 87.5, yes. This is especially important because human performance is comparable at 85% threshold. So being above this is a major milestone. And we have never tested a system that has done this or any model that has done this beforehand. So this is new territory in the ARC AGI world. Congratulations with that.
Congratulations for making such a great benchmark.
Yeah. When I look at these scores, I realize I need to switch my worldview a little bit. I need to fix my AI intuitions about what AI can actually do and what it's capable of, especially in this O3 world. But
O3
the work
world.
also is not over yet.
It's
And these
crazy.
are still the early days of AI. So we need more enduring benchmarks like ARC AGI to help measure and guide progress. And I am excited to accelerate that progress. And I'm excited to partner with OpenAI next year to develop our next frontier benchmark.
Amazing. You know, it's also a benchmark that we've been targeting, been on our mind for a very long time. So we're excited to work with you in the future.
Worth mentioning that we target and we think it's an awesome benchmark.
Yeah.
We didn't go do
We didn't
specific
do
work for
specific
this. This is
things,
just,
yeah, sure.
you know, the general of 3. But yeah, really appreciate the partnership. And
Yeah.
this was a fun one to do.
Absolutely. And even though this is done so well, ArcPrize will continue in 2025. And anybody can find out more at arcprize.org.
Great. Thank you so much.
Artprice.org. All right.
Okay, so next up, we're going to talk about O3 Mini. O3 Mini is a thing that we're really, really excited about, and Hongyu, who trained the model, will come out and join us.
Hey.
How are you? Hey.
Hi everyone, I'm Hongyu Ren. I'm an OpenAI researcher working on reasoning. So this September, we released O1 Mini, which is an efficient reasoning model in the O1 family that's really capable of coding, probably among the best in the world, given the low cost. Now, together with O3, I'm very happy to tell you more about O3 Mini, which is a brand new model in the O3 family that truly defines a new cost-efficient reasoning frontier.
It's incredible.
Though it's not available to our users today, we are opening access to the model to our safety and security researchers to test the model out. With the release of adaptive thinking time in the API a couple of days ago, for O3 mini, we'll support 3 different options: low, medium, and high reasoning effort. So the users can freely adjust the thinking time based on their different use cases. So for example, for some, we may want the model to think longer for more complicated problems and think shorter with like simpler ones. With that, I'm happy to show the first set of evals of O3 mini. So on the left-hand side, we show the coding evals. So it's like code versus ELO, which measures how good a programmer is, and the higher is better. So as we can see on the plot, with more thinking time, O3 mini is able to have like increasing ELO, outperforming O1 mini, and with like median thinking time, it's able to measure even better than O1.
Yes, it's like for an order of magnitude more speed and cost, we can deliver the same code performance on this
or even better.
or even better.
I just
right?
placed the
So
ARC
although it's
website
like,
there
O3
for
mini high is
reference.
still like a couple 100 points away from Mark. It's not far. It's better than me, probably.
But just an incredible
see.
sort of cost to performance gain over
exactly.
what we've been able to offer with O1, and I think people will really love this.
Yeah, I hope so. So on the right-hand plot, we show the estimated cost versus code versus ELO trade-off. So it's pretty clear that O3 mini defines like a new cost-efficient reasoning frontier on coding. So it's achieved like better performance, compared better performance than O1 with a fraction of cost.
I don't have access to
With
O3
that
yet
being said,
on ChatGPT's
I would
website.
like to do a live demo
That sounds great.
on O3 mini. And hopefully you can test out all the 3 different like low, medium, high thinking time.
I mean, they said it's not open to public, and it is only open for safety testing. I'm checking if I have API access or in Playground. But they're showing a cool
So
demo.
I'm testing out O3 mini high first, and the task.
Looks like they're buffering. Or is it my browser problem? What?
That I'm asking
shit,
the
sorry.
model to use Python to implement a code generator and executor. So if I launch this, run this like Python script, it will launch a server and locally with a UI that contains a text box, and then we can make coding requests in a text box. It will send the request to call O3 mini API. And O3 mini API will solve the task and return a piece of code. And it will then save the code locally on my desktop and then open a terminal to execute the code automatically. So it's a
Very complicated.
pretty
business
complicated
steps.
task, right? And it outputs like a big chunk of code. So if we copy the code and paste it to our server, and then we would like to launch this server.
So we should get a text box when you're launching it.
Yeah.
Okay, great. Oh yeah,
I hope so.
Yeah.
It seems to
That's
be
good.
launching something.
Okay.
Oh, great! We have a UI where we can enter some coding prompts. Let's try out a simple one, like print OpenAI and a random number.
Print OpenAI and a random number.
So it's sending the request to O3 mini medium, so it should be pretty fast, right? So on this
41.
terminal.
Okay, so he has access to the model.
Right?
I was wondering, like, where is he playing with all
To
this?
this like local script on the desktop
I get it.
and then print out
Okay,
OpenAI
makes sense.
41.
Cool, have fun.
Is there any other tasks you guys want to test it out?
I wonder if you could get it to get its own GPQA numbers.
That's a great ask. Just as what I expected. We practiced a lot yesterday.
What?
Okay, so
I didn't
now
get
let's
the
copy
problem he said.
code. And send it in the code UI. So in this task, we asked the model to
Generatable.
evaluate O3 mini with the low reasoning effort on
Oh, I
this
see.
hard GPQA dataset. and the model needs to first download the raw file from this URL, and then it needs to figure out which part is a question, which part is the answer, or which part is the options, right? And then formulate all the questions, and then ask the model to
That is
answer
so
it,
fun,
and then
man.
parse the result, and then
Prototyping
grade
and
it.
testing
That's actually great.
with OpenAI
It's
and
actually pretty fast because it's
checking out
all
their
these,
newest models.
training this low reasoning
It is
effort.
so fun.
Yeah, let's see how it goes.
These two tests are
Yeah.
really hard here.
Yeah, the long tail is solving the problem.
This is so cool. It's almost done. Let's see.
GPK is a hard data set.
Yes.
Yeah, it contains like maybe 196 easy problems to really hard problems.
While we're waiting for this, do you want to show what the request was again?
That was my literally the same thing I was wondering.
1.62%.
Okay, that's very high.
Right? This is a low reasoning effort model, and it's actually pretty fast. Then full evaluation in a minute.
Somehow very cool to like just ask a model to evaluate itself. Like
Yeah,
this.
exactly, right? And if we just summarize what we just did, we asked the model to write a script to evaluate itself on this like hard GPQA data set.
This is so cool.
from
Like, I mean, they
the
just
UI, right, from this code generator and executor created by the model itself in the first place.
Next year, we're gonna bring you on, and you're gonna have to improve.
it's very cool. They just showed the full cycle of how it's all working and how the whole thing was done by the AI itself, the O3 model.
Besides code forces and GPQA, the model is also a pretty good math model. So we show on this plot with like on this AMI 2024 dataset, O3 mini low achieves comparable performance with O1 mini, and O3 mini median achieves like comparable better performance than O1 if we check the solid bar, which are pass of ones.
O3 mini
And
high is
further
pretty
push
close to
performance
O3.
with O3 mini high, right? And on the right-hand side plot, when we measure the latency on this like anonymized O1 preview traffic, we show that O3 mini low drastically reduced the latency of O1 mini, right? Almost like achieving comparable latency with GPT-4o. Right, it's under a second, so probably it's like instant response. And O3 mini median is like half the latency of O1.
So yeah,
And here's another set of evals that I'm even more excited to show you guys is API features, right? We get a lot of requests from our developer communities to support like function calling, structured outputs, developer messages.
this is very cool. So if O3 is going to be coming with structured outputs, function calling,
all these features, same as
I don't know what is live bench coding, but
and notably, it
yeah,
achieves, like,
it's going to be very cool.
comparable better performance than for all on most of the evals, providing a more cost-effective solution to our developers.
Live bench coding, let's see what is it.
And if we actually unveil the true GPQA diamond performance that I ran a couple of days ago, it actually also means it's like 62%. I mean, basically, ask them to evaluate itself, right? And we should totally just model to automate the evaluation instead of have to. So with that, that's it for
Some sort of
for me,
benchmark.
and I hope our user can have a much better user experience early next year.
Fantastic work.
Yeah, thank you
really
so much.
great work.
Yeah, thank you.
Cool. So I know you're excited to get this in your own hands, and we're working very hard to post-train this model to do some safety interventions on top of the model, and we're doing a lot of internal safety testing right now. But something new we're doing this time is we're also opening up this model to external safety testing, starting today with O3 Mini, and also eventually with O3. So how do you get early access as a safety researcher or a security researcher?
Yes, tell
you
us.
go to our website, and you can see a form like this one that you see on the screen.
Oh man.
And applications for this form are rolling. They'll close on January 10th. And we really invite you to apply. We're excited to see what kind of things that you can explore with this and what kind of jailbreaks and other things you discover. Cool. So one other thing that I'm excited to talk about is a new report that we published, I think yesterday or today, that advances our safety program. And this is a new technique called deliberative alignment. Typically, when we do safety training on top of our models, we're trying to learn this decision boundary of what's safe and what's unsafe, right? And usually it's just through showing examples, pure examples of this is a safe prompt, this is an unsafe prompt. But we can now leverage the reasoning capabilities that we have on our model to find a more accurate safety boundary here. And this technique, called deliberative alignment, allows us to take a safety spec, allows the model to...
O3 model is not on their
and
website
also
yet.
just tell,
The
this
form
a
is not there yet.
Oftentimes within the reasoning, they'll just uncover that, hey, this user's trying to trick me, or they're expressing this kind of intent that's hidden. So even if you kind of try to cipher your prompts, oftentimes the reasoning will break that. And the primary result you see is in this figure that's shown over here. We have our performance on a rejection benchmark on the x-axis and on over refusals on the y-axis.
Oh, nice.
And here to the right is better. So this is our ability to
Beautiful
accurately
graph.
tell when we should reject something, also our ability to tell when we should refuse something. And typically you think of these two metrics as having some sort of trade-off.
It's really hard to do well.
Yes,
It is
there should be a
really-
trade-off.
yeah.
Right
but
in
it's
the
also
conjointing
deliberative
place.
alignment that we can get these two green points on the top right, whereas the previous models, the red and blue points, signify the performance of our previous models. So we're really starting to leverage leverage reasoning to get better safety.
Yeah, I think this is a really great result of safety.
Yeah, fantastic.
Okay, so to sum this up, O3 Mini and O3, apply please if you'd like for safety testing to help us test these models as an additional step. We plan to launch O3 Mini around the end of January and full O3 shortly after that. But that will, the more people can help us safety test, the more we can make sure we hit that. So please check it out. And thanks for following along with us with this. It's been a lot of fun for us. We hope you've enjoyed it too. Merry Christmas.
Merry Christmas.
Yeah. So that was it for today. Not bad. I mean, it was a pretty good show. Good launch, good everything. And that's it for the live streams. And we should be done with these. And I will see you next time.